In this video, we're going to go through the process of setting up and carrying out a one-way delay test on X.21 using the Albedo Ether.Genius product. Now, to do this test, you need two Albedo Ether.Geniuses, one each end of the communication circuit, and the Albedo Ether.Genius needs to be equipped with a GPS, GNSS option, and also the Datacom option, and in particular you need the X.21 data cable. Now, the first thing we're going to do is connect our Datacom cable to the Ether.Genius unit. This is done on the bottom of the unit, and there are two ports marked DTE and DCE. Now, depending if you're using a DTE X.21 cable or a DCE X.21 cable, you connect it to the appropriate port on the unit. Now, for our particular example, we're going to actually be using both DTE and DCE, and I'm going to start off connecting the DCE cable to the unit. The other thing you need to do is to attach the GPS aerial to the GNSS connector on the top of the unit, and then we're ready to start setting up the test. So now with the unit switched on and at the main menu, we're going to start setting up the Ether.Genius for the X.21 one-way delay test. Now, the first thing we normally do is we reset the unit to factory default, so we click on the system button, to hit escape to get up to the top level here menu, and we're going to go down to reset to factory settings, select enter, and then go down, scroll down and enter yes. That resets the unit, takes out any inherent settings that may be left over from other tests, and make sure we're starting from a clean point of view. So now we go back up to the main menu, and we want to go to the setup screen. Now, because we're doing a one-way delay test, we need to use the external GPS timing. So we want to go down, scroll down here to the reference clock, and make sure we select input clock, then scroll all the way down to the bottom and select GNSS. That will now use the external GPS aerial as our timing source. If we click on the LEDs button, we can see that the green reference light has come on, means we've got a GPS input signal, but we're not locked yet. The signal's not locked, we've still got amber, so we just have to wait a while until we get lock on the GPS signal. But we can carry on doing our setup, so I'm just going to hit escape. And now I'm going to scroll back up to the mode, and in this case we're in Datacom mode. We want to use the X.21 Datacom, so we're going to go scroll down to Datacom endpoint, and we're going to select the Datacom endpoint mode. Now we can scroll down to Datacom and up to line, and we want to select the mode of operation. Now in this case it's already set to V11 or X.21, so that's fine. Now we can set the mode here to either DTE or DC. Now this once again depends on what cable we're going to be using. If we're using a DTE cable or a DCE cable. Now normally if you're doing a test through, for example, an X.21 modem, then you would be a DTE and the modem would be a DCE, and you'd derive all your timing from that DCE modem. Or if you actually want to emulate a DTE, then obviously you'd select the we're going to select a DCE, then you'd have to select the DCE mode here. Now, when we're doing next one-way delay test, we do need to calibrate the unit and take out the inherent delay, so we only measure the delay on the actual X.21 circuit. So to do that, if we've got a modem which we can connect to and we can press a loop button on it, then that's great because we can calibrate it that way. But if we don't have a modem with for example, a loop capability, then we have to manually apply a loop to the unit and do our calibration, in which case we need to select a DCE mode and use the DCE cable. So I'm going to do that. I'm going to, in my configuration here, I'm going to set to DCE. Now, the rest I can leave the same. I can leave the clock synchronous and synthesized, and all I have to do here is now set the line rate that I want to test at. Now I'm going to leave it in a 64 kilobits per second, but I could go in here and change that at a different speed. But we're going to leave it, for the purpose of this test, we're going to leave it at 64 kilobits per second. So now I've set up the operation for DCE for 64 kilobits per second. So now I can hit the escape key, go back up the top level menu or the home key. Now I'm going to go over to the test menu and set up the test. Now the type of test I want to run, if I go to the right, sorry, I've gone too far there, if it's a delay test, so I can scroll down to the delay test. I can enable the delay test. I can then scroll down. I want to set a one-way delay test. Now this is where I can calibrate the unit. Now I need to make sure I've got my DCE cable plugged in. As I say, if I was connected to a modem, then I'd be setting this as DTE. As long as that modem's got a loopback capability, loopback button, I can press on the front of it to loop the transmit to the receive. So now I've connected my X.21 DCE cable, and I've just got plugged in the end a loopback to loop back the transmit to receive, and you can just see on this picture here an example of the loopback cable. And once all that's set, I can just go into this menu here, adjust zero offset, scroll up to adjust and press enter, and now you can see it's come back and saying ready, and it's measured the inherent delay in the unit, and now we're ready to actually carry out the test. So in this case, what I'm then going to do is I'm going to, depending on my connection, I could either go back and to my setup, into Telecom, into line, and I could change that back to a DTE if I've got a DTE cable. My particular example here, I've got 2 units back to back, so I'm actually going to leave this as DCE because the other unit's configured as a DTE. So now I'm just going to connect the 2 units together, and then to get the test results we simply go to the main menu, scroll along to results, press enter. We can go up and down till we get to the delay, press enter, and now you can see that we're measuring the full round trip delay, the forward path delay, return path delay, and the asymmetry on the X.21 circuit. Now there is a accuracy of around about plus minus 10 microseconds, so that's why we're seeing a measurement here of about 8 microseconds, even though we're connected back to back. But one thing you'll notice here is that the minimum and maximum aren't updating at the moment, and that's because we aren't actually running the test, even though it is carrying out a measurement. If we press the run button on the front of the unit, then as well as the current, we get a minimum and maximum if we run this test over a period of time. Now at the bottom you'll also note we've got the remote host, which is the serial number of the device at the far end. And one thing I should mention is you get results at both ends, so depending either end you are of the X.21 circuit, you get these results. So you can see the round trip, forward path, return path, and the symmetry measurements at either end. And that brings us to the end of carrying out a one-way delay measurement for X.21 on the Ether.Genius product.